gentlemen, looking at our warm-up. In order to get the stamp today, what do you need to do? Use complete sentences. So if I'm asking, what are you doing, you would answer, or you would start with,
I'm doing.
I am, whatever. So start with I am for your complete sentence. Thank you for waiting, Cameron. Ladies and gentlemen.
The game costs about 60.
Thank you. So, anybody have anything they want to share? What are they doing over Thanksgiving? Ops? If someone is talking, you're listening. This is the only time I'm talking to this today. It happens again in the hall.
Okay.
Ops?
I'm going to Wisconsin to do the race, the high school race.
How far is it?
It's like 5K.
Who's all going to be in Wisconsin? Like, just people in Wisconsin, and who are you racing against?
I'm going to race to the other because I'm trying to stay all over the station.
Awesome. Jay?
I'm chilling with the fam, and I have conference championship.
Conference championship for what?
Football.
Cool. Is it conference champ, or is it like for the Greek team?
Yeah.
Isn't it like the state championship or just conference? Okay. Is this like a lower level?
If you win this game, you go to
The state championship. Cool. Hold on one second. Cameron, Chica, what are we doing? Space forward, please. Someone else is talking to listening. Awesome. Good.
Nashville, Tennessee, family.
Cool. What family you have in Nashville?
It's my dad's side.
Okay. Driving or flying?
Yeah.
Give me a long drive.
Yeah.
Cool. Everybody else? I have one of my college roommates, his family always gets a condo in Vail for the week, so I will be up on Thanksgiving. I'll have Thanksgiving dinner with them. Good family friends. This year it's just going to be me and their family, but in years past, like my family's actually come out to celebrate Thanksgiving with them. So that's what I got going on. But basically, we all know we have a 2-day week this week. In our 2-day week, we need to make sure we're taking care of things. We've got a lot on our plates, including what we're doing today. We are looking at the idea of chemical compounds. This is a prerequisite skill in order to balance chemical reactions. Has anybody balanced chemical reactions before in middle school? One of us? Yeah. Maybe a couple of us? So in order to be able to balance a chemical reaction, we need to be familiar with chemical compounds, and specifically we need to be able to count the number of atoms in those compounds. And you can also see, and we've had this warm-up before, a warm-up similar, where we've needed to write in complete sentences in order to get the stamp. That's one of our objectives today too, is just being able to communicate our ideas using complete sentences. Before we get started on that, let's take out our keep our warm-ups out. It's the last day. We are going to turn those in. How many points? What's the total number of stamps you have? 9. 9. So put your total out of 9. So it should look like this. Chemical bonding notes are on the front side. 9.5 is the back side. We have not finished 9.5 yet.
I left it.
Don't have another copy. You should look for it. Are your notes out yet? So some of the stuff that we're going to take today is going to be a little bit of a review, but it's going to help us moving forward. You know this one, right? So you probably took it home to study. Find the one that has this side.
It's home, I remember.
Okay, so then you're going to write it on a piece of paper.
Yeah, I know I'm doing that.
And then you're going to copy it on your notes.
I'm going to do that.
So same thing with you, Jesus. Writing it on notebook paper and then transferring it. So, chemical compounds. What do we mean by chemical compounds? Write it down. So, chemical compounds, we have 2 or more atoms that are bonded together. We just got done with bonding. Who can tell me, what are the two types of bonds that we have, or what are the two types we studied? Obs, give me one.
Ionic band.
Ionic bond. Who can tell me what is an ionic bond? Cameron.
It's when it's non-metal and metal.
Metal and non-metal, and what do the electrons do? You can't remember, but you flip over the notes and look. So ionic bond is metal and non-metal, and it is the transfer of valence electrons. So if the electrons are being transferred, the atoms are bonded together ionically. So you got the other type of bond?
Covalent?
Covalent bond. Who can tell me what is a covalent bond? Chica.
They're sharing the nickel and non-metal.
Only nonmetals, and they're sharing the electrons. So, we just got done studying bonding. Now we're applying that knowledge to our slide today. Because we have our two different types of compounds. It can either be ionic, and it can be the transfer, or it can be covalent, where they're shared. So, when we look at the individual chemical compounds, or the chemical formulas, we have three different parts. We got the symbols, we have things called subscripts, and we have things called coefficients. We should already be pretty familiar with with symbols. It's the subscripts and coefficients that we're going to spend some more time with. So the first thing, element symbols. So, element symbols. First letter is always capitalized, and we've seen that before. If there is a second letter, it's always lowercase. And I know I've stressed this difference, and we've done a really good job making sure that we've listened to that difference, but we need to make sure we continue doing that not only in this class, but as you move forward in your science career. And that way it helps us distinguish or differentiate between a big C and a little o. By the way, what element would this be? Anybody know? No.
It's not alcohol.
Oh, carbon.
Somebody said it.
Carbon.
Not carbon. What's on the periodic table? Element number 27. Not copper. Somebody said it was?
Jay, you said it.
Cobalt. It's cobalt. So cobalt versus, what's going on here? Carbon and oxygen. And so that's why it's very key to differentiate between those, because cobalt is way different from carbon and oxygen. The only way you can tell that apart is this letter is capitalized, so it's a new element. This letter is lowercase, so it's part of the same element. And so we've talked about that difference. So ultimately, what that does is the symbols tell us the different elements that are in a compound. And so we should have a place to write down the answers for this. In this first one, how many elements, class, are in this one? Two. What are they? What is that name?
Sodium.
Sodium and
Chlorine.
chlorine. So we got two elements in that first one. So all you have to do in that first blank is just write two. In the second one, how many? Three. What are they? Magnesium, carbon, oxygen. But we're just counting the different elements, like Mg is uno, is magnesium, carbon and oxygen. We're not worried about the numbers yet. That's coming. Question?
How can you mix to put the thing like O3?
So right now, we're not concerned with the numbers. We're coming to that in the next slide. We just need to realize that there's magnesium, there's carbon, there's oxygen. We've got three elements. This Mg is one element because that G is lowercase.
I know.
So now this next slide, and you guys just asked the same question, and that's what we're talking about, those little numbers. They're called subscripts. Prefix sub mean? Anybody? Roman? Below. So anytime we see a subscript, it's a number that's written below. So it's a little number written below. So subscripts are written after and below a symbol. Basically, the subscripts are going to show, or they're going to tell us the number of atoms there are for that particular element. If a subscript happens to be written after parentheses, and we'll see an example of that, then it applies to all elements inside. And then finally, if it is unwritten, it's assumed to be a 1. So looking at the questions that we have here, how many atoms for each element? First of all, how many different elements do we have in this one class? 2. We got H, we got O. How many H's do we have? 2, because this subscript applies to the H because it's written after and below it. So in this one, in the little blank, you'd write H equals how many? 2. So write H equals 2. What about oxygen? How many oxygens are there? One. Who can explain to me why is there one oxygen? George? Which rule helps you figure out that there's one oxygen? Shown, maybe number 4. Because do you see a subscript here? After the O. So that if you don't see one, if it's unwritten, what is it always assumed to be? A 1. So anytime it's not written, it's always a 1. So there's one oxygen. In this second example, parts. How many different elements do I have in this second example?
3.
3, what are they?
D, I don't know what that is, but hydrogen and oxygen.
I mean, you can just tell me the letters, it's fine. C is carbon, though.
Okay.
Carbon, hydrogen, oxygen, perfect. How many carbons do I have?
6.
How many hydrogens?
12.
12. How many oxygens?
6.
Pretty straightforward. Just listen to the subscripts. All right, who thinks they can do this third one? Cameron, what do you got for us?
AL, O, and H,
Al, O, and H.
and O has 3 and H has 3.
What about Al?
Doesn't have 1. Wait. H has, it has 1.
1. Anybody have any questions on how Cameron got that? You have a question on that, Daniel? Oh, sorry, equals, thank you. I sometimes put dashes, but I'll put equals so we're not confused. Anybody have any, Jesus, you got a question on how we got that? Well, first of all, it's not a 0, it's oxygen, it's an O. So, Jesus' question is, why does oxygen have a 3? Who can explain that? What do you think?
Because because then the parentheses, and then the 3 belongs to inside the parentheses.
Perfect. Can anybody think of that mathematical term that says that 3 goes to everything inside? Roman, you have it? The distribution. It's like the distribution property, right? The 3 gets distributed. So this 3 goes to everything inside the parentheses. And so, Jesus, is the AL inside the parentheses?
No.
Does the AL have a number?
Yes. No.
And well, it doesn't have a number, so it's 1. But then both of these are inside the parentheses, so those 3 go to both of them. So it's distribution, and we will use that idea a lot. So, Kaden, you can just leave that right there, thank you. Coefficients. So, has anybody studied scientific notation? Scientific notation? In scientific notation, you have a number times something to a power, times 10 to a power. That number in front is referred to as a coefficient. And so that's the same thing that we're looking at here. It's the big number written in front. Ultimately, the coefficient is going to tell us the number of compounds that are present. Here's a key step, number 3. If there's both a coefficient and a subscript, what do you think this X signifies? Multiplication. So you're going to multiply whatever the coefficient is times the subscript to figure out the total atoms, or the total for that element. And then once again, if you don't write the coefficient, if there doesn't appear to be anything there, then it's always assumed to be a 1. So our question, how many atoms for each element? Who haven't I heard from it? Kim, I don't think I heard from you today. How many different elements do I have in this first one? What are they? Sodium and chlorine, Na and Cl. How many sodiums do I have in this case, Kim? What was that? 1. Well, I have the subscript would be a 1, but do I have anything maybe in front? 5. A 5, so that's the coefficient. What do I do with the coefficients and subscripts? So what do we get when we multiply them? 5. What about for chlorine? 5. So class, what this is saying is by having this 5 here, that's basically telling me that I have 5 compounds of NaCl. So NaCl1, NaCl2, NaCl3, NaCl4, NaCl5. So you could go ahead and count each of the sodiums and you get 5, just like Kim told us. Or we could realize that it's 5 times 1 for the sodium, and then it's 5 times 1 for the chlorine. Let's see it. In this next one, so I got H and O. How many H's do I have?
4.
So I got 2 times 2 is 4. How many O's? 2. Because it's 2 times 2, and then 2 times 1. So let's try to put it all together now, make it a little bit more challenging. So I think I got 4 challenge problems, well, not even challenge problems necessarily, but 4 problems on the bottom here. So let's go ahead and work through this first one together, and then you're going to have these next 3 on your own, and then we will check our answers. So the directions say, find the number of atoms for each element, then find the total. So Amir, I know you're not technically part of this class, but we'll have you participate anyway. What elements do I have in this? How many different elements do I have?
3.
So what are they?
So, hydrogen.
H?
Yeah.
Perfect. What else?
And, sulfur.
Sulfur and?
And, oxygen.
Perfect. Omir, how many H's do I have? How many hydrogens do I have?
So, 2 hydrogen.
Yep. How many sulfurs?
4. 3 and 1.
Does that 4 touch the S?
No.
So it's just?
1. So 1.
Just 1. And how many oxygens?
4.
4. So then, class, when it says, then find the total, who can tell me, how do you find the total? Daniel. Adam. Adam up. What do you get, Daniel?
No way. 8. No way. 7.
7. So then the final step, ladies and gentlemen, let's make sure you give me the total. So list how many you have for each. Adam to get the total. Na, how many NAs?
1.
1. What's next?
2.
H is 2. What's next?
P.
P is how many?
1. Then O is 4.
O is 4 for a total of?
8.
1, 2, 1 is 4 plus 4 is 8. Perfect. And example number 3, how many H's?
3. No, 6.
6, because we multiply. How many P's?
2.
2. So I know Paris has this right now. Does everybody see why that's 2?
Yes.
It's 2 times 1. Perfect. All right, and then O is 8. For a total of? 16. And this last one, a little bit tricky.
1.
B, how many?
1.
3.
Oh, 6. Oh, no, but
O is what?
6.
6.
8.
And H is 6. For a total of? 15. Does anybody have any questions why O and H are both 6? You want to know why? Who can explain to Daniel why are O and H both 6? Quincy Berger. So what do we call that too? If it's the little and afterwards. What do we call the 2 here in this case? It's an example of a subscript. So we distribute the subscript to both of them. She's correct. So the 2 goes to the O and the H. So Daniel, how many O's do I have? Like, ignore the 3 for a second. How many O's? 2. And how many H's? 2. Okay. And then what's the next step? And what do we call the 3? The coefficient. So then after you distribute the 2, then you multiply everything by 3. So remember, you just told me there's 2 O's. So then we take the 2 times, which is, and then we have 2 H's, so then 2 times. Got it? BE, does the 2 go to the BE? No, so the BE is just, so that's why the BE is 3. Just the thing. So ladies and gentlemen, please take out page 199. Absolutely. Have I ever said you can't use your notes?
Yeah.
Only on a test. That's it. Otherwise, you can always use your notes. Okay, here we go, ladies and gentlemen. Let's do this first one together on page 199. Hey, gentlemen. So the first one, we're not gonna listen to what the directions say, because I don't like them. We're just going to do basically the same idea that we've been working with. So what is the first formula? Number one, what's it say? CaCl2. How many CAs do we have? One. How many Cl's do we have?
Two.
And for a total of? On the front side, are there any coefficients?
No.
No. You do need to add to get the total, but there are no coefficients. Flip it to the back side once.
Coefficient.
There are coefficients on 11 through 20. So today's an individual one. Tomorrow we're going to have some more challenging ones that we're going to work with partners. So go ahead and start working on that. If you have a question, raise your hand.